Okay, here's warm-up 6.3. OIN invests $200 at 3% interest, compounded quarterly. So this little phrase is important because it's going to direct me to the right formula to use. So compounding quarterly means that 4 times per year we're adding the 3% of the money back into the pot. So that means we need the formula that has n's in it. Since our n, if our n was just 1, we could do this with just 1 plus r to the t times a. But we need the ones with the n's there, okay? So starting amount is 200, so that's going to go where the a is. The a is the starting amount, the y is the finishing amount. I don't know that yet. That's what I'm solving for. Okay? The rate, be careful with the rate. The rate is 3%, but we want to write that as a decimal, so 0.03. And then n is 4. There's another n up there in the exponent, and the time is 10 years. Okay, so I'm going to do this with a calculator. I'm going to start with this fraction and work my way out from there. And I'm going to try to not round as I go. If you were writing down your steps, you have to round a little bit to write them down. But you want to keep the nice long decimals you're creating in your calculator. Okay, so that is that fraction, and I'm going to add 1 to that. So okay, and 4 times 10 in the exponent, that would be 40. So then make sure you do the exponent before the multiplication to follow PEMDAS. So I'm going to take 1.0075 to the 40th, and then the last thing is multiply by 200. And we wind up with $269. I'm not going to go to the nearest cent, always for money problems, and 67 cents. Okay. All right. And OIN's brother Gloin also invests money. So here we got $300 at 4%. This time it's compounded continuously. So we're constantly adding the 4% back into the pot, and that means we need another formula, and this is the one that has E in it. So it's going to look like that, okay? So we don't know the final amount yet. The beginning amount's 300. E is just a number like pi. It's about 2.17 or 2.712, is it? Maybe I'm forgetting. Okay, but it's programmed into your calculator. The rate is 4%. And then the time is 11 years. Okay, so there's my setup. And common mistake here is that people take 300e and raise it to that exponent. But the 300 isn't raised to that exponent, only the e is. So what I want to do is take e raised to 0.04 times 11. Okay, so 0.04 times 11 is 0.44. Throw that pen away. Okay, 300, and I've got e to the 0.44. So yeah, I need to do this first, then multiply by 300 last. Okay, so the e button, it's above the division button, so you can hit second divide, but you can also go second and then find this ln button down here, and then it has the exponent set up for you already. So e to the 0.44 is about 1.55. And then multiply by 300. And then got my final amount. Okay? All right. So, I'm going to use E on the rest of these problems. I'm simplifying expressions that have E in them. So E is a number. So it's programmed into your calculator. So you hit second divide, and there it is. And if you hit enter, it'll tell you the value. So yeah, about 2.72, 2.718. I don't know what I said before. But it's just a variable. So I'm not going to actually get the decimal versions. I'm just going to simplify these in terms of E. So this would work the same as if I had x to the 8th times x to the 3rd. So, if these were x's, well, then I'd have 11 x's all multiplied together. Here I just have 11 e's all multiplied together. So, that means I can just add the exponents together when I have the same base and I'm multiplying. So this is going to be e to the 11th, yeah. And I'm not going to type that in my calculator. You could get the decimal version, but I'm just simplifying in terms of e for these, okay? All right, so this one, what I can do is I can I can rearrange this. This is all just multiplied together. So I can think of it like this. And then 2 times 3 is 6, and e to the 4th times e to the 5th, that would be 9 e's all multiplied together. So this is going to be 6e to the 9th, okay? Ones like this, I like to think of it like that. 42 divided by 7 is 6. And then e to the 8th over e to the 2nd, well, 2 of the e's would cancel out, and I'd be left with 6 e's in the numerator. But you can also just do 8 minus 2, like that, when you have a fraction. So this is going to be 6e to the 6th. So there's different ways to approach that, but going to end up with 6e to the 6th no matter what. Okay, same kind of deal here. So 81 divided by 9 is 9. And then for the e's, it's not going to be e to the 4th because I have to do the top one minus the bottom one. If you did the canceling, the 3 e's on top would cancel. You'd be left with 4 e's in the denominator. But you can also just do the subtraction like so. So then I've got 9e to the negative 4th. But I don't want to leave a negative exponent in my final answer. So I'm going to take this piece and think of that as 1 over e to the 4th. Okay, and the common mistake is people will write this as 1 over 9e to the 4th, but the 9 doesn't go in the denominator. The 9 is going to stay where it is because it doesn't have a negative exponent. The negative exponent is only for the e, not for the 9. It's not the quantity 9e raised to the negative 4th, in other words. Okay, so here is my solution for that one. Okay, all right, quite a few different ways you can handle this one. What I'm going to do is raise both the 6 to the 4th and the e to the negative 5x to the 4th. So I'm thinking of this as 6 to the 4th times e to the negative 5x also to the 4th. Okay. And I'm going to use a calculator for 6 to the 4th because that's a large number. That comes out to 1296. Okay, and then when I've got an exponent raised to another exponent, you multiply the exponents together. So I'm going to multiply these together to get negative 20x. Okay, and then again, I don't want to leave a negative exponent in my answer. So I'm going to take this part and think of that as 1 over e to the 20x. Okay, and now this would be 1296 over 1 if you want to think about it like that. So if you multiply straight across, there we go, no negative exponent, and I've simplified that as much as I can. Okay, all right, that's the end of the warm-up, and I'll see you next time.